Do you want to learn how you can build a Calendly clone using either serverless or more traditional architecture? In this video, that is exactly what we're going to be talking about and showing you how to do. Now, this is going to be a bit of a special episode as I have a guest on called Denis, who is a traditional architecture expert. And what we've decided to do is to take the idea of cloning the Calendly app, and we're kind of going to battle it out. So we're going to see how I would do it in serverless and how Denis would do it in a more traditional architecture. So Denis, do you want to introduce yourself?
Yeah, thanks, Sam. My name is Denis Chahuk. I'm a software architect and coach. Combine the essences of life coaching and traditional work coaching, technology coaching into the field of software engineering.
So in this video, what we're going to be doing, I'm going to share my screen now. And we have set up a couple of requirements for kind of the app that we want to build. So it's obviously Calendly, which is an app that allows you to basically send out a link and have your users, customers, or just anyone who wants to book a meeting with you, and it integrates into your calendar. So our core requirements are that you can create an account, obviously, and then connect with your existing Google Calendar. You can then set some working hours. So like what times are people allowed to book meetings with you? You can then share that calendar with whoever you want. They can click on that and a guest can then schedule a meeting where they have a choice of all of the time slots that you've said are available in the working hours, but making sure there are no conflicts with your existing calendar events. Now, once you've got that core functionality, we decided to add the ability to upgrade to a business account. Now, this comes with a couple of extra benefits, such as being able to have a group or a team. And in this team, you're able to manage each other's calendars, manage each other's working hours. And that is what we're offering as our business account. And finally, we want to be able to send notifications to a user if an event is changed or cancelled. So to start with, I'm going to be going first with my first little chunk, and it's going to be user sign up. So I'm going to paste this in here, and it's going to start with a business owner who can use the AppSync API. Now, when a user actually signs up, then we're going to actually get some details from them inside the UI so that they can log in with Cognito directly. This Cognito authenticated AppSync API is then going to call one of our business logic lambdas. And this is going to first write some user data about this business owner into a single Dynamo table. As well as that, we're then going to trigger SES to basically send an email to that user saying, thank you for signing up, but also giving them a link to go and connect their Google Calendar. So that is the next step.
What I do want to highlight is that we've created, it's not the same system per se, right?
Yeah,
So what we're doing is we're also sort of exploring how two different architects think about the process of architecture and how we've made differences in interpretation of what the requirements were and what the use cases were and sort of what went under our radar. That's something that really fascinates me. What I like to do with architects when I'm coaching them is find new ways for them to think about a system.
Yeah, and I think it's going to be very interesting seeing how different my approach is to your approach. So let's go to the second one. So now a user has either by being sent directly the link and being redirected, or by clicking on the link in the original email, they've gone to their calendar and they get to that UI where it says, do you want to allow this app to be able to have these permissions? They've hit yes, okay. That's going to then hit a webhook call to a API gateway. And the reason I've done these kind of separately is because default for webhooks is either a post request or a get request. And most webhooks aren't associated with GraphQL. So I thought I'd keep them separate. So from that webhook, we hit a Lambda, which does some verification, make sure that the webhook is valid. And from there, we can actually update the Dynamo table record for this business owner to say, here is some information about this user's calendar connection. And before we wrote from Lambda to Dynamo, but here we're going to use Dynamo streams. So whenever a record is written to Dynamo or updated in Dynamo, that event can be automatically streamed to a Lambda. So that's like another way we're going to be triggering a Lambda. But that Lambda is going to do something quite similar to before. It's going to hit SES. That's going to send another email to the business owner saying, congratulations, you've hooked up your calendar. And maybe here is the link you need to send out to your users so that they can actually book an event. The next one is actually being able to set which hours this business owner wants to be able to set meetings in. So in this case, it's basically using exactly the same pathways as before, where we use AppSync. That then hits Cognito to verify that it is who they say they are. That hits another one of our business logic APIs, or Lambdas, should I say. And here,
Sam. May I chime in?
Yeah.
When you said it's going through AppSync, so we're talking about GraphQL mutations specifically?
Yes.
So this would be a different mutation and it hits a different Lambda.
Yeah, so a different mutation hitting a different Lambda. And the reason I haven't listed every single Lambda here is because it's more the pattern of AppSync going to a Lambda. And yeah, there could be 20,
and
there could be 30.
Out.
And then from there, each Lambda has its own custom business logic.
Okay.
But the pathway, the journey, and like how I think of the architecture is going to be relatively similar. So from there, we're going to write to DynamoDB, again, with a record about the hours that the business owner wants to be able to be contacted in. And this is probably something that you've not probably gone into as much detail with, but because it's DynamoDB and it's single table, what we can do and what I've actually done is created a relatively simple database schema. So we have what kind of data is it? And then the fields. So every field has an ID, so it's uniquely identifiable. And normally that is just an ID. And then there is a partition key and a sort key. These two things can be kind of combined to make unique queries. So when we first sign up the user, they can add we add a user ID with their name, their age. If they want, they could add things like their LinkedIn profile or their other social media platforms. And at that point, we don't know what hours, but with that second API request, which is set my availability, we create a second record. In here, we can set things like what days they're available, what times they're available on those days. And you can also, because it's a NoSQL database, you can put basically whatever records you want in here. So you could put a flag saying, do you want to make me available on national holidays? As well as that, we can get things like the calendar connection. So whenever we actually authenticate with Google Calendar, we can store that data. But now what we can do is if we want to say, actually get me everything I know about Sam Williams, I can just query where PK equals my user ID, and I get back all three of these records. Instead of having to query 3 separate databases or 3 separate tables, it can be queried at once. But if I want to say, get just my calendar details, I can say, get me where PK is my user ID and SK equals calendar. Another thing we talked about is later on being able to upgrade to a pro or a business account. And for that, I want to, in advance, basically make an organization for every single user, which later they can add a company name and schema and logo, and that will be used for billing later on. But if we create it in advance, we have it there and it's ready, so there's less work when we need to actually upgrade.
I just wanted to highlight that the difference between you and I is that I have very little serverless experience. So perhaps to give some background on why we're doing this is I saw that you're specializing in software architecture and you're just doing serverless. Like you're like super focusing on serverless. And I don't have a lot of experience with serverless. Like maybe it's a style of architecture. Maybe there's just some architects that prefer serverless and some architects that prefer machine services or microservices or monoliths in some kind of hosted space, still in the cloud, but not what you would call a function as a service, right?
When, like, for myself, when I learn serverless and like when I build serverless apps, I'm always looking for, is there a use case here? Is that a use case inside this application or inside these business requirements that either sooner or even later, it's going to either cause me to be kind of stuck in a corner or cause me to have to just rewrite it and make it server based. That's always something I'm watching out for. But I think serverless, once you know how to put it together and once you're used to thinking in a serverless kind of way, it can actually be applied to a lot more systems and a lot more architecture and a lot more problems than people initially think. Shall we go on to your first stage of design?
Yeah, I'm just starting from the user and reverse engineering it back to the understanding, to the use case. So I immediately realized that there are like two types of people, two types of users. A host is somebody who owns the calendar, and a guest is somebody who wants to, have a meeting with this person who owns the calendar. So I differentiated the blue and red paths specifically for those two types of users, because they will be using the similar APIs, but they might have different use cases in mind for those APIs. So coming from a domain-driven design background, I immediately try to figure out, okay, what are the key terminology themes? What are like some 3 core business areas? And I quickly saw that, okay, there's something to do with calendars and accounts. There's something to do regarding specifically with meetings. And there's that concept of the premium accounts or the businesses. So I split it out. I did like a high level overview of the use cases, of the contexts of possible data streams. And specifically on the screen right now is generally I look for where these areas touch, which I call the overlaps, which is appearing on screen right now. And generally the most complexity is happening on the overlaps. So not in like one particular context, but where 2 contexts touch. I'm writing down now from intuition based on the use case where those complicated overlaps might happen and how we might call that. So I'm setting that aside. And I'm preparing the playing field for, okay, there's probably 3 good candidates for contexts. And that wraps up my stage 1. On the left side, I have external services. And on the next step, I will start drawing lines that will embody the flows through the system. So basically, okay. I'm taking the text that's on the screen and I'm splitting it out, refining it into further detail.
So it's really interesting how your approach has been very much like, what are the large moving parts? That's a very different approach to how I've designed software and how I tend to think. But it's a really cool approach. And especially looking in advance to what are the external services and how might they interact with both my internal services and then obviously the services interacting with each other. I think that's a very different way of approaching it, but I like it. So now we're going to move on to my part 2, and my part 2 resolves around actually booking an appointment. So some other person is going to be able to make a request to AppSync, which is then going to make a request to a Lambda function for get availability. This Lambda is going to do 2 things. First, it's going to go to our single table, and it's then going to pull back the data that the user has set around the days of the week, the times of the day, and whether they work on holidays. Now that we have that, we can make a request all the way up to Google Calendar to say, for the person who is the owner of this calendar, get me their availability for probably the next week or the next 2 weeks. I can then combine those availability slots with the availability that the user has set in their config inside Calendly. And I now have a way of basically generating all of the slots that are available for this user, and I can send that back via AppSync. So now the other person, the person who's trying to book a meeting, knows exactly all of the slots that are available, and that's what they're then going to choose, one of those slots. And the next API call they make is going to be, again, through AppSync for creating a meeting. Now, the first thing that's going to happen is in this create meeting, we are going to get the availability again from Dynamo, because the business owner may have updated it in between the user first viewing it and then actually confirming a specific meeting slot. So with that, we can basically check that also the person is actually wanting to meet within the required or within the specified availability time of the owner. From there, the Lambda will make a request to Calendly to basically add the meeting to the calendar. At this point, if there is a conflict or anything like that, because the calendar itself is updated, that will be handled by the Lambda. But assuming everything goes well, the response will go back to the other person or to the person who is booking the meeting saying that has been booked. Behind the scenes, Google Calendar will then take that new event. It will look at all of the participants in the event and will send an email to both the business owner and to the person who has booked this meeting saying there has been a meeting that has been set up. So in this case, it's actually really simple. There are just two Lambdas and basically the same pathway for both getting and booking meetings. And this is one of the nice things about AWS and Lambda, is that each Lambda can be completely isolated and they have one task to do, and you don't have to worry about building and managing a server to handle all of the meeting events when there may literally be two endpoints.
Okay, now we're in my second one. It's going to be a slow one because I did a lot of thinking here about how to separate them out. So I'm just leveling the playing field to create those three contexts. I try to separate out a very clear picture that, okay, I have three contexts. Let's create like three separate services. They might be microservices at this point. I just want to separate out the databases so I don't couple them accidentally. What I'm doing here is I'm trying to put back onto the landscape where the seams are touching and moving together. So generally there will be some complexity. I don't know yet. I haven't decided yet what that complexity will be, but I am starting to put them on the map. So that here I'm separating out the EC2 instances, and I'm constantly putting like a REST API in front of everything. Sort of like a mini API that will host the microservice. In my example, I've combined the registration flow with the connect calendar flow. So my API endpoints capture the main use case, which is a host has a particular landing page, which is them having connected their Google Calendar, and then they share it to a guest. The guest opens up their landing page, they connect their own calendar, which creates their account, and then the UI shows free slots, which are overlaps of the two calendars. And then they can schedule a meeting based on those overlaps. If you remember, my red user was the guest, my blue user was the host. So I'm just creating flows where the host registers his calendar, which would create an account, the guest registers a calendar, which would create his account, and then the scheduling links are slowly joined together. The host will receive the API called the blue line, which will allow him or her to set their availability. And that will then sync up with the guest account. I think now what's coming on screen is the little domain model to signify the meeting preferences. Meeting preferences meaning the working hours or holidays. So this first microservice is really about authorization and finding overlaps on calendars.
Yeah.
Right. It has nothing to do with meetings. Right? It's just about getting into the system and finding overlaps. The reasoning behind separating meetings was that the meetings are the thing that communicates with Google Calendar. And it is the only microservice that understands this externality. Because if we didn't combine it with Google Calendar, if you had, say, an iCal and you would export it into a physical file and send it to the email, the account management system actually wouldn't have to change that much. So I saw like a clear separation of concerns there that I wanted to highlight with a separate, strong, like meetings-oriented cluster.
So should we move on to the next section?
Yeah.
Back onto me. So this is my the end of mine, which is the business sign up. And it's going to start with like as a business owner, I want to basically hit that buy button. I'm going to have most of the Stripe logic in the UI. So you'll use Stripe and you'll use the direct debit or the monthly billing API. I can't remember what it's called exactly, but that will basically give us back a token saying, here is their ongoing billing details, credentials or token. That will get sent via AppSync to an upgrade Lambda, which will basically store those Stripe details as well as like if we had multiple tiers of premium membership. So yeah, if there was different levels you could unlock, then what level they've got, as well as some details around when the next invoice is expected. So that can get all written to Dynamo. And then we go back the same old way, SES, to send an email to the user saying, congratulations, you have successfully signed up for the premium membership. And one of the big features we offered was actually saying that when you are a premium member, you can add other people to your team. So as a business owner, now that I am a paying member, I have access to the invite method on GraphQL that basically gets a Lambda function, which then stores an invite record into DynamoDB, which is basically a pending user. And the reason I do that is because if you just said, oh, anyone can now join this account, you're going to have spammers who are going to attack or use the wrong email address and try and become a member of your organization so that they can access your calendar. Doing this way, you can specify someone is allowed to join my organization if and only when their email equals this and their ID equals this, for example. That's obviously then going to send out an email to that user, and that user is then able to accept the invite. So as the user, I can hit that same GraphQL API, but this time it won't be authorized because this is the first time they're ever contacting the system. At that point, there'll be a process that allows them to sign up. But because we can check in this database these details, we can say, hey, you're trying to join an organization that hasn't sent you an invite. Basically, what are you doing? Or in our case, we can hopefully say, yes, you've got an invite. Business owner over here has invited you to the complete coding organization. Then we can use that to generate them a Cognito user and give them a login so that if they need to access the calendars or the availability details of anyone else in the organization, we can have the group set on Cognito so that we're able to say, yes, this person does actually have access to the calendar of business owner. Now, the next kind of challenge is with payments. So now you've got a user and they can interact with each other's calendars because they've signed up. But a month later, what happens if the card fails? So we're going to start with Stripe, and Stripe is going to hit that same webhook we used earlier for Google. And that webhook is going to call a Lambda. And depending on what's happened, if they've successfully made a payment, then that can go through and just write to a Dynamo table saying, here was an invoice and it's been paid. If there was a missed payment, then we can store that missed payment also in DynamoDB. And this missed payment can also send a reminder email to them saying, hey, you've missed a payment. Here's a quick link to update your card details. And that can point to a hosted Stripe where they can update whatever details they need to. One extra little thing that I've added on here is added a TTL or a time to live to my Dynamo table. So I can say, store this missed payment inside DynamoDB and say that if that record doesn't get updated or changed in the next, say, 3 days or a week, then automatically expire it, which will then trigger a second Lambda. This second Lambda will be like okay, they've not paid and they've not responded to that email address. At that point, you can do a couple of things. You can disable the fact that they are in premium membership. You can change some records in the Dynamo table to revoke that access. And of course, you can send them another email saying, hey, you didn't pay, and it's been a week. So we've changed your access permissions. Please go to this link if you want to basically become a paying member again and just update your card details. So with all this and the billing side of things, I'm adding a couple of extra things to our single table design. So first, when you sign up, you can add a company name, a website, a URL. You can add a color scheme so that whenever a user lands on your landing page for your calendar, you've got the logo and your branded color scheme. As well as that, we then have our organization billing info, which is basically the data we get back from Stripe. And as before, it has a common partition key of the organization ID. This means I can say, get me all the information about this organization by just querying on that partition key. I can also go down deeper and say organization and SK equals details. One other cool thing is when a user accepts one of those invites, we can create an organization user. And here we're basically creating a new user. They'll have their own availability. They'll have their own calendar connection. That will work exactly the same. The difference will be that they will have a record of organization user, which will have the same organization ID. So this is called a compound key. So I can say, get me all records where partition key equals my organization ID and SK starts with user hashtag. That will basically get me all of the users in that organization.
It might be a stupid question, but you keep using the word partitions.
Yes.
My understanding of DynamoDB is that it is one giant atomic partition globally. Is that incorrect?
So it is, if you a single table is a single unit, but the way behind the scenes they store it, they don't store it all on one hard drive. What they do is if you have a partition key, every single unique value for this is stored on its own hard drive.
That makes sense.
So if you're querying, you're always querying where you know a partition key. So with that partition key, and by the way, if you're not doing single table design, you don't have to call them PK and SK. It could be anything you want. It's just that with single table design, having a generic name makes it more understandable. One other thing I wanted to talk about is the fact that you can have multiple global secondary indexes. So if you want to query on data in a Dynamo table in a different way, you have to create another index to query on. So in this example, I've got an invoice. That invoice has an ID, an organization ID, and then the sort key is invoice hashtag, and then the date. So I could say on index 1, get me for this organization, everything where SK starts with invoice. And that would basically get me all of the invoices that this organization has ever received. I could also say, get me where organization ID equals this, and invoice is between invoice hashtag 6 months ago and invoice hashtag now. And you can do this between as well as begins with, and there's quite a few other methods that Dynamo gives you. So yeah, you could get like a 6-month block of invoices from like last year if you wanted, and that's all doable inside the sort key. But if I was like, okay, I'm an admin, I want to get all of the invoices for January, I wouldn't be able to do that with this because the data is never grouped by the month. So I can create a second index where I say the index partition key is going to be invoice and then the year, and then the month. So each month is going to be grouped together in a Dynamo partition, and then it is sorted by the status, hashtag, the organization ID. So there I could say, instead of querying on index 1, query on index 2, saying invoice hashtag 2020 hashtag 01. And that would get me every invoice from that month. And I could use the sort key to say, get me every January 2020 invoice, where the SK starts with unpaid, because I want to get all invoices that are still unpaid from that time period. So do you want to move on to your last?
Yeah, let's go. So what I'm doing here, I'm putting in place the cancel link. The cancel link is particular to the cancellation API, where somebody got a URL inside the meeting request. They can click it, sort of free up the slot. So the system gets, so the system is in sync for that particular purpose, because we had a use case for it that seemed practical. And now I'm modeling the business landing page. So I decided to have a different interpretation of a business than you did, Sam.
Okay.
What I did was that I said that a host user account can decide to upgrade by paying a Stripe subscription. And when that Stripe subscription is successful, a business gets created. And that is encompassed into the business's API. And then what happens is that up to 3 accounts can then be linked. Basically, 3 host accounts can be given access to this business account. And the business account has its own calendar. That is how I schematically set it up, because the business account also has its own link, but its own landing page with its own branding information. And then there's new API connections now coming up, but now it's sort of starting to make sense in that the Google accounts are being connected for the business, the local accounts, because usually you have a business Google Calendar for like a particular business, right? So all 3 of them will be invited, and then one of them can accept and then show up for the meeting. That is how my interpretation is slightly different from yours. Again, for anybody watching who's sort of learning to be either a software architect or a serverless architect, this is points where we disagreed are definitely things where it is not obvious that you need to ask further questions to your subject matter expert, to your product owner, to your perhaps project manager, or even just business representative of, hey, are we doing it like this? Do you want this detail? Do you want that detail? So I'm really glad that we had some very organic differences in the way that they decided to set it up. And now I've linked it up at the bottom to like Stripe to come into the business, and successful subscription payments. Like I think you used direct charges. I opted to use subscriptions, and then a payment status update to that subscription generates an invoice that we can email them later. And primarily, this business account now has its own landing page with its own preferences. And the host that has access, the first host that created the business, has normal access and has an extra configuration page that he or she can use to modify the branding settings, the meeting preferences for particularly this business. Did I miss anything?
So it's very interesting how you've like grouped, well, you're basically creating a separate server or a separate, at least, REST API for each of your internal like functionality groups, or
it's like treated like a microservice, but then scaling becomes a problem when you want to scale meetings independently with account creation, which is what I was going for here.
I think that's one of the things that we should probably mention, is that we had one call for an hour to discuss basically how this was going to work and just talk through the use cases. We didn't talk about scalability. We didn't talk about security. We didn't talk about a lot of these things that are very important when you are designing a commercial application. Now we're just kind of talking through them because it's interesting. I find it interesting how what your approach is.
What I found interesting was this sort of flow.
Yeah.
There seems to be like when I look at your diagram, you know, what I split up into 2 contexts for you is a bunch of Lambda icons, but they are grouped. So when I look at your screen now, they are grouped.
Yeah.
But in the traditional architecting, where let's say they cohabit a single microservice, or let's say they're in a monorepo and it's still captured in like a encapsulated in like a module or folder, and then it captures the cardinality of how they cohabit, of maybe how they are coupled together by being in that folder. What is the equivalent of that for Lambda functions?
You can do basically exactly the same thing. You can have like your folder structure, which says these 20 lambdas or these 10 lambdas are my user sign up lambdas or user management lambdas. These next ones are my meetings lambdas, and these ones are my business lambdas. You can have that. And someone was like, oh, Lambda doesn't work. It's like, how do I apply my microservice approach to Lambda? But Lambda is like kind of almost like the epitome of microservices, because each Lambda,
it's like a nano service,
it's
like a pico service.
It's this Lambda, ideally, a Lambda has one job to do one task, whether it's to get something from a database, write something to a database. It should have a single functionality. So it's like having the smallest microservices you can, and then you can group those functions into more what you would normally consider as like a microservice of user management.
Now, this is a quick note from me as I'm editing this. So this interview actually lasted about an hour and a half, and I've obviously had to cut it down to make it shorter and easier to digest. But if you do want to watch the full thing, that will be linked below, where we go into more detail comparing our different systems and also diving deep into things like single table design and the approach that Denis has taken around designing architecture, especially when you consider like multi-region and international deployments.
Oh, Sam, I just wanted to thank you for inviting me and for being open to the suggestion. This was really fun. We did it for the first time, and I think we should do this again sometime. Thank you for doing your contribution to the architecture space, to the engineering space, and especially the serverless space. So you can find me under Coach Denis or Denis Chachuk. My LinkedIn is definitely my main links and connections hub. If you want to reach out to me, connect with me, send me an email, or just directly book something on my Calendly. Yeah, this was a blast, and thank you.
Yeah.
And to the viewers, thank you for your time and spending this much to watch till the end.
So thank you very much for watching, and all of those links will be in the description underneath this video. And I just want to say thank you as well to you, Denis, because yeah, I've definitely had my thoughts challenged and had a different approach discussed. So it's always good to like open up from what you normally do and yeah, basically find out what other people are doing and how that can help you become a better developer, even in the serverless world. So yeah, thank you very much.